Hello Year 8, we're heading towards the end of our topic now on linear graphs. What we want to do is apply some of the skills that we have learned to help us with some more practical questions. So we're going to go straight into the examples here today. The first example says, a shop owner finds the number of DVD players sold each week, which we're going to call N for the number of DVD players, decreases as the price, P, increases. That kind of makes sense. You don't sell as many if the price gets more, okay? So this relationship can be given by the rule. So they're giving us a rule. N is the number of DVD players sold and P is the price, and it's 150 minus 0.3P. So it says complete the table below. So we've been given some values for P that we want to substitute into that formula. So if N is equal to 100, we're going to put the 100 in where that P is. So that means we have 150 minus 0.3, and we need a times sign because that's times by P, and P is 100. If we press equals, that means that they've sold 120, so N is 120 DVD players. Okay, we now want to do when P equals 200. So you could type the whole thing in again, or you can just change your 100 to a 200. And that means they're going to sell 90 DVD players. And then we want to put in that P is 400. So we change this to be 400. And that means they're going to sell 30 DVD players. Okay, once we've managed to fill in the table, then we want to graph the relationship between the number of DVD players sold and their price. So it means we just want to draw the graph. So I'm going to use my ruler just to make my axes look right. Now, because this is, we don't have any negative values in here, we can draw up an axis that just is just like the first quadrant of our Cartesian plane because we don't have any negatives. So just all in one corner here. Okay, so across the horizontal axis, across the bottom here, is going to be P, standing for the price, and N is going to be on the vertical. So whatever pronumeral is on the top of your table, that is going to be your horizontal axis, because that's where the X would normally be, your X axis, and the bottom number is what goes on your Y axis. So we're going to need to pick a scale here. We can't have 400 spaces on our graph. So for our P, maybe we'll go up by 50s. So across the bottom here, I'm going to go 50, 100, 150, 200, 250, 300, 350, 400 for P. The biggest number that I have for N is 120. Maybe I could go up by tens. So I'll go 10. Oops, let me try that part again. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay, so you want to make sure that you're picking a scale that is spreading your graph out as much as you can, but still is going to fit on the graph paper provided. So to plot the points that we've been given, when P is equal to 100, so down here at 100, N is equal to 120. We are here. When P is equal to 200, N is equal to 90. And when P is equal to 400, N is equal to 30. Okay, so that should be making a nice straight line. Let's check it with our ruler. Yes, lovely and straight. And we can draw a line going through there. Oh, it's a little bit off there at the top. Okay, so that's it. That's all that we had to do for question 1. Example 2 on the next page. A hiker walks at a constant rate of 4 kilometers per hour for 4 hours. Draw a table of value using t for the time in hours and d for the distance in kilometers. Use t between 0 and 4. So they've already got the t values in there for us. So starting when time is 0, 1, 2, 3, 4 hours. That's how long this person's going for a walk. They're doing 4 kilometers every hour. So that means at the very beginning, they've obviously walked no kilometers. So no time, no distance. In 1 hour, they're going to walk 4 kilometers. In 2 hours, they're going to tongue-tied. They're going to walk another 4 kilometers, which will make a total of 8. Another 4 kilometers later will be 12, plus another 4 will make that 16. Then we want to draw a table. So remember what I said? The t is on the top here, so that is going to come to the horizontal axis, and we want to get up to t equals 4. So 0 is going to be on the corner, 1, 2, 3, and 4. The d then will be on the vertical axis, and that goes up to 16. So I'm not going to have enough space there to go up by 1s, but hopefully I have enough space to go by 2. So 2, 4, 6, 8, 10, 12, 14, 16. Now we plot the points. So 0, 0 would be right here at the starting corner. Then t is 1, distance is 4. 2 goes to 8, 3 goes to 12, and 4 goes to 16. And again, we get a beautiful straight line to represent that problem. Okay, now this question asks us to go a little bit further than the last one. It says, write a rule linking D with T. Now, if you remember, we did a lesson on trying to find the rule when you have a table of values like this. And what we did was we said, well, what are these going up by as we go across the bottom here? And they're going up by 4. There are little plus 4s as we go across here. If you can, I'm just squeezing those in there, plus 4. Okay, so if they're going up by 4, that means that D is going to be equal to 4 times by the other pronumeral T. Then whatever is underneath the 0, which happens to be another 0, gets added on the end. So it'd be 4T plus 0, but we don't actually need to write a plus 0. We're not actually adding on anything. So D is equal to 4T would be the rule for that line. Part D says, use the rule to find the distance traveled for 2.5 hours of walking. Now, it has specifically said here that you need to use the rule, which means this equation that I found. Some of you may be tempted to come up here and read things off your graph. You may be accurate with that, but if it has asked you to use the rule, then you must show that you have used that formula. So the formula was D equals 4T. My time is 2.5 hours. So I just want to substitute that in to my equation. So D equals 4 times by T, but my time is 2.5. So all I do is times those together. 4 times 2.5 is 10. We need some units there. Now, we're working at the distance, and the distance, it says up here in the question, is in kilometers. Okay, so he is going to walk 10 kilometers in 2.5 hours. And in part E, it says, use your rule to find the time taken to travel 8 kilometers. So again, we have to use the rule. Our rule is D equals 4T. This time we've been told that our distance is 8. So underneath the D, that's going to be 8 equals 4T. To find out what the time is, I'm going to have to divide by 4 to cancel that off. And T will be by itself. 8 divided by 4 is 2, and the units of that will be in hours. So it will take 2 hours to travel 8 kilometers, which we could also have known by looking at our graph or looking at our table. But it did say to use the rule, so we've shown that we can use the rule to do that as well. Okay, so they're the kind of questions that you're going to be answering today. So you're working on exercise 11.